Today's lesson is 12.5, volume of pyramids and cones. That is the goal as well. So our volume of pyramids and cones are 1/3 base times height. Now notice, previously surface area of these were base plus half perimeter times slant height. Height and slant height are different. Height, slant height, and typically half side length of a regular form a right triangle. So if they only give you two of the three, we can use Pythagorean to solve. Most of the problems in today's lesson will have the height given to you and will have information given to you so that you can find area of the base by just plugging the numbers in. Again, B is capital B for area of the base, just like it was in yesterday's lesson. So it's not just one number, it will be one calculation. Volume of a cone is 1/3 base height. However, your base is a circle, so it is 1/3 pi r squared height. It will only have two units, whereas normally on here we've got typically three sides. So it makes it a little bit simpler to calculate, and since it has pi involved in it, you're going to be plugging it into your calculator anyway. Going through pyramids first, we've got find the volume of the solid, round your answers to the nearest hundredth. So again, as we continue to go through these, every time I'll remind you in these videos to try to be thinking of the formula we just learned and what is that fraction, because when you have surface area formulas, volume formulas all given to you, you still need to discern which one's which. So in this case, 1/3 base times height. Base is going to be 6 times 4. So 6 times 4 is 24. And 1/3 of that is going to be 8, and then the height is 8. So I'm thinking our answer right here, we could plug it in the calculator, but we should also get 64 centimeters cubed as our answer. Next, we've got a regular pentagon that is a pyramid. So this is a pentagonal pyramid, and so they've given us the height here is 9. A little bit off, but 9. Each side is 8, and the apothem is 5.51 meters. They solved it for us, right? So there's our apothem, there's our sides. If you're thinking of your formula, base is half ANS. I give you AS, what is N? 1, 2, 3, 4, 5. It is the number of sides. I said pentagon, so it's 5, right? So 1/3 base times height. I would just plug in the numbers here. I don't need to have just base solved by itself. So 1/3 times half, 5.51 times 5 and times 8, and then times the height 9. Do not forget the height. It is very common that given a regular polygon is a lot of calculation. It is easy to forget the height, but do not forget that height at the end. When we calculate this, round to the nearest hundred, I get 330.61 meters cubed. Next one, we're back to a nicer, simpler shape. We've got 9 by 9 on the bottom, 14-foot height. Try this one on your own. And our answer is 1/3 base times height is 1/3 9 squared times 14, giving you 378 feet cubed. Moving on to cylinders, cones, pardon me. Now in this example, they gave you slant height, but the height is right there, just we're looking for the up and down value. So even though you've got three values, square root of 39 is the one we'll be using. 8 you will not be using. Okay, so volume is area of the base times height. Well, this is 1/3 pi r squared height. So plugging it in, r is going to be 5, height is going to be square root of 39. We have pi there as well. And rounding to the nearest hundredth, I get 163.49 meters cubed. And again, with some of these calculations, I just want to remind you guys that Desmos is available. Desmos.com/scientific is the website for this kind of decent working calculator. And so how we would do just what we did there, 1 divided by 3 gives me the fraction already, right? And then we had pi times, and then just clicking back, we had 5 squared, square root of 39. So 5 square button times square root 39. And you can do all that probably even quicker than you could on a TI calculator to get 163.493. So just 0.49 rounding down, meters cubed. Okay. Next, and some of these kind of are different colored shape, but in general, when I have the arrow running from top to bottom, that is signifying the height. It may not always be pointing exactly to the apex of the cone, but just as long as it gives me enough space to put the label inside there is typically how much space I'll have for that. Moving on, 1/3 pi r squared height. This is not radius, so we're going to have to do a little bit of math. 14 divided by 2 gives us 7 is our radius. So 1/3 pi 7 squared times 9 gives us 416.81 inches cubed. One more of these. Try it on your own. And now that you've unpaused the video, 1/3 pi r squared height gives us 1/3 6 squared, pi times 6 squared times 8, giving you 301.59 centimeters cubed. Last question is, given the volume of a right cone, right meaning it's not oblique, it's up and down, is 1350 pi meters cubed, and the radius is 18 meters, find the height of the cone. Okay, so volume equals 1/3 pi r squared height. They give us height is 18, volume is 1350 pi, so plugging it in, well, 18 divided by 3 is 6. So I'm just going to rewrite this. I'm going to divide by 6 pi on both sides. I don't need to rewrite it. If you can do that simple math, 18 divided by 3 is 6. We've got 6 pi r squared, so we divide by 6 pi on both sides. 6 goes into 1350, the pi's cancel. 225 times, so what times itself equals 225. You can use your square root button if you didn't know, but we're going to get 15 and then add the label back in. It was meters, so our final answer is radius is 15 meters.